हेलो फ्रेंड्स, एक बार फिर से आपका स्वागत है मेरे चैनल फार्मास्यूटिक्स लेक्चर बाय डॉक्टर शिल्पी प्रसाद में। आज मैं आप लोगों के साथ फिर से क्वेश्चन पेपर डिस्कस करने आई हूँ, जो फिजिकल फार्मास्यूटिक्स 1 का क्वेश्चन पेपर है। बी फार्मेसी थर्ड सेमेस्टर में CSVTU भिलाई द्वारा लिया गया था। तो चलिए स्टार्ट करते हैं। दिस इज द फर्स्ट पेज ऑफ क्वेश्चन पेपर। फर्स्ट टोटल मार्क्स 75, आउट ऑफ दिस 20 marks is of MCQs and 20 marks long answer, and then 35 marks is of short answer question. We will solve today the MCQs of this question paper. So first question is, which of the following properties of a particle significantly affects the physical, chemical and biological properties of the drug? So you can see that basically we study in micromeritics about the particle size and different particles related to the fundamental properties of the powder and then derived properties of the powder. And in that, these basically all these are like density, that is the derived property of powder. Sedimentation is actually not a property of powder. From this we can determine the particle size. Then particle size के ऊपर surface area depend करता है, and the surface area is very important, that is determining basically affecting the physical, chemical and biological properties of the drug, because more is the surface area, more the powder is exposed to absorption, distribution, metabolism and excretion, and moreover it is that's physical properties of the powder like solubility, that also depends on the surface area. As you increase the surface area, more is the solubility. So by reducing the particle size, you can increase the surface area. So many things depend on the surface area, even absorption, adsorption, all these things depends on surface area. So this is the basic property which significantly affect the drug properties of the drug. The next question, the type of particle diameter obtained largely depends on that particle. You have seen that there are different methods for particle size determination, like microscopic method hai, then sedimentation method hai, counter method is there, and sieving method is there. And the method by which the particle size is determined, the diameter is known by that method. Like microscopic method से अगर आप particle size determine कर रहे हो तो उसको कहलाएगा वो projected diameter, और अगर आप sieving method से determine कर रहे हो तो वो de-sieve कहलाता है. If you are determining it by sedimentation method तो फिर वो कहलाता है Stokes diameter. तो इस तरीके से अलग अलग पार्टिकल डायमीटर के नाम है डिपेंडिंग ऑन द मेथड बाय विच इट इज डिटरमाइंड. सो आंसर इज मेथड ए. Which one of these distributions is more important in the design of dosage form? So while designing of dosage form, the uniformity of the dose is very important, and for dose uniformity, the weight is very important, the weight of the powder or the weight distribution of the powder. So in this, the answer will be weight. Going to the next question, moving. Fisher subsieve sizer is used to determine the surface area of powder. You know very well that subsurface area can be determined by Fisher subsieve sizer, and that is based on air permeability method. Okay, so the surface area is measured based on the change in. So what is there? What is the change here? What happens when we want to determine the surface area of the powder? We first fill it in a compact cylindrical vessel, and then air is passed through that. Since air is passed through, the particles get aligned in the form of capillaries, and then air is passing through it. In that case, what happens that there is some resistance, that the resistance is offered because of the particles. So that resistance is actually converted in the form of pressure drop. There is a pressure drop while air is flowing through that compacted powder, and that pressure is actually measured, and that is converted in the form of particle surface area. So by Cogency-Karman, I think the equation name is Cogency-Karman. So with that help of that Cogency-Karman equation, we can change the pressure drop in the form of the surface area of the powder. So the answer will be pressure across the compacted powder. What is the nature of the drug which commonly binds to human serum albumin? It is related with, this question is related with protein drug binding, and while we have studied the protein drug binding, we know that what type of proteins binds to which type of drugs. Like albumin binds to basically acidic and neutral drugs, but here though both the options are there, so mostly it binds to acidic drugs. So answer will be acidic drugs. The next question, coming to the next question, complex stability constant is increased if the ligand is having. So complex stability constant actually depends on the amount of or the concentration of the complex formed. More the complex is formed, more stable is the complex, more will be the stability constant. And how how it will be more stable, or how the concentration of that product, that complex, will be more, that will depend on the high electron density of the donor, that is the ligand. More is the electron density, or more is the more basicity is there of the ligand, or if there is more charge density on the ligand, then it will have better stability, and better stability constant will be there, then complex will have better stability. So answer will be high electron density. Coming to the next question, the role of hydrogen bonding between species in complexation can be highlighted when the solvent employed is, so solvent employed is non-polar. You know, hydrogen bonding occurs between an electronegative and highly electronegative and electropositive atoms. So here non-polar compounds which are having such type of atoms can get bonded with hydrogen bonding. So the answer will be non-polar. The next question, in most of the complexes, metal ions and ligands are involved. So metal ion and ligand are respectively. So metal ion is actually the Lewis acid and the ligand is the Lewis base. Why? Because the ligand donates ligand is the donor and metal ion is the acceptor. So this will be the answer. This is Lewis acid and base. Coming to the next question, dielectric constant is a property applied for. Actually, by the help of dielectric constant, polarity scale is prepared, and in that polarity scale, water is having the highest dielectric constant, that is around 78.5. It is having the highest, and in vacuum there is a lowest, I think that is the lowest dielectric constant. So answer will be polarity scale, because with the help of dielectric constant we can't do any structural elucidation, or you can't derive the percent composition, or qualitative analysis can also not be done, but we can apply this for formation of polarity scale. Next question, which of the following favors the formation of solids? Formation of solids, आपने जब when you have gone through this phase diagram of pressure temperature diagram of water, in that case you must have seen that it is almost like this, and in that this one is the solid. That means the solid phase exists when the pressure is low and the temperature is also low. So solid actually is a very stable form of matter, and that only exists when there is low temperature. So when there is low temperature, then only solid formation will be favored. So answer will be low temperature. Then next question, coming to the next question, who explained that there were attractions between the gas molecules? So as you see, the options, you go through the options, you can see that there are Boyle's law, Raoult's law. Raoult's law actually ideal solution and non-ideal solution is related with ideal and non-ideal solution. Then Boyle's law and Charles' law is related with the ideal gas equation. But this van der Waals force of attraction, this scientist only determined or said that gas molecules have attractions also, and that is very weak attraction, but they have attractions. So that is van der Waals. Van der Waals will be the answer. Which of the following intermolecular attractions are responsible for lower boiling points of a liquid? You know, lower boiling point, that means liquid is having very weaker forces of attraction, and you can see out of these four, the most weakest force of attraction is called as London forces. Okay, so London forces actually is responsible for the lower boiling point of a liquid. So London forces, after London forces, the next more stronger attraction is hydrogen bonding, and after that it is dipole forces, and after that it is ion dipole forces. So the weakest is London forces, and the strongest is out of these is ion dipole forces. So answer will be London forces. Hemolysis is observed in one of the following solutions. This question is related with the tonicity question, methods of adjusting tonicity, pH and isotonic solutions, buffered isotonic solutions. So hemolysis is observed when the RBCs are kept in hypotonic solution. Hypotonic, that means having less tonicity or less concentration than RBC, and in that case, since it has less concentration, because of the osmosis process, the solvent will move from low to high concentration, and the solvent starts moving from low hypotonic solution to RBCs, and then RBC gets where it swelled and then it burst and then it causes hemolysis. So the answer will be hypertonic solution. Then which one of the following solutions has higher buffer capacity? So high buffer capacity, that is denoted as beta, can be written as number of molecules of or the concentration of the added buffer and the change in the pH. The concentration of the acid or base, whatever be the concentration of the acid and base, and the change in the pH. Since buffer capacity is directly proportional to the concentration of the acid or base, so as you increase the concentration, the buffer capacity will increase. So out of these, the highest concentration is 1m, so answer will be 1m. Which is the factor that influences the pH of the buffer solution? Now pH, the factors which influences the pH of a buffer solution, that is temperature. As you have must have seen that in a pH meter also there is a temperature knob also. So temperature actually affects the ionic concentration of the hydrogen ion concentration. So temperature will be the answer. Now next is when CO2 is dissolved in water, what is the nature of the solution? As you know, when CO2 dissolved in water, what will be formed? Carbonic acid will be formed and the nature of the solution will be acidic. So answer will be acidic. Coming to the next question. Dynamic equilibrium exists in one of the following solutions: dilute or supersaturated or saturated or unsaturated. As you know, in this case, when the solution is saturated, that means solid is in equilibrium with liquid. And this is a dynamic equilibrium. Why? Because it can be changed by changing the temperature. The solubility can be changed by changing the temperature. So the saturated solution, in case of saturated solution only, there is a dynamic equilibrium existing between solid and actually solid in solute form, and then in this case the solid is in, you can say it is actually it's liquid, it is the solution form. So you can say it is again the solid in solution form. It is in solution form. The solid is in equilibrium in both the phases. It is in either in solid form or in the liquid form. So it is the case, or the answer will be saturated solution. The next question: which of the following solid forms has low aqueous solubility? So as you know, polymorph is something different, and in case of amorphous, crystalline, the more solubility has got amorphous, crystalline has got lower solubility, lower aqueous solubility. And in case of anhydrides and hydrides, anhydrides have got more aqueous solubility. So in this case the answer will be crystalline, because it has got low aqueous solubility as compared to other forms of the solid. Then which of the following modes of expressing concentration is independent of temperature? Independent of temperature, that means there should be no volume factor in this, because volume can change with temperature. So in this case, if either formality here we are taking, or mole fraction, or molarity, or normality, all these things have got, actually except mole fraction, formality, normality, molarity, all has got the, because what is molarity? That is the moles of solute per liter of solution. Per liter again is the volume. So wherever is the volume, there is a factor in the formula, then it will be dependent on temperature. So in case of mole fraction only, it is independent of temperature. Mole fraction is denoted as xi, and xi is equal to the moles of solute. Suppose moles of solute of A and the total moles. Suppose there are two components, A and B, so total moles A and B. So, and it is independent of any volume factor, so answer will be mole fraction. Okay. So mole fraction is only independent of temperature, otherwise formality and molarity and normality, these are all dependent on temperature. Why? Because all has got a volume as a factor in the equation. Next is vapor pressure composition plots are used in the method of, so vapor pressure composition plots are used in the method of azeotropic distillation. Why? Because in azeotropes, what are azeotropes? These are constant boiling point mixtures, and a constant boiling point mixture may, when you have seen the graph or when you have plotted it, you must have seen that in x-axis we take the composition and on y-axis we take the vapor pressure. So azeotropic distillation plots are used in the method of this one. Rest others are not there. So these all are the answers of MCQs. And in case of long question, first question is what is the specific surface of particles? So you must be knowing that there are two specific surfaces, specific surface area of by volume or by weight. So these actually specific surface is only specific surface area. So you can determine what is the specific surface of particles and describe one method to determine it experimentally. So you can determine it by either adsorption method or by Fisher subsynthesizer. Any method you can write down here. And then what is tonicity, and then explain methods for adjusting the tonicity. So these questions are all as per the syllabus. So thank you very much. This is all the question paper, all about the question paper. Thanks for watching.